Dear students, good morning. How are you today? So, I would like to talk about regressions and what a regression is. So, actually, we talk about that problem. We want to have a function. We want to have a function that represents the coronavirus cases growth. So right now, we know that this is an exponential because the way the virus is spread during an outbreak, it's exponential. So we have something like this. So we have a multiplying factor that will be the base. And then we have just the number of cases at the beginning when it starts. Okay, so now we're gonna use Desmos to do this regression and to find A and B. Okay, we already said in the previous video that B must be close to 1.3, right? So and I'm gonna link this at the bottom of the video so you guys can see you can use the link to do it yourself. Okay, so here we go. Here I have a table where I have all the values beginning from the day that you think that the data is valuable. So I have started with 0. I don't remember what day is that. Must be Sunday in February. And then that day we had 35 cases, then it went to 53, blah, blah, blah. And it just went up. Okay. Then, yeah, here I have a table of where this is number 7, right? Number 7 is the last value, where I put it here, maybe here, right? So number 7 was the last value. Then I need to put 8. The 8, whatever day it is, we had 100 cases. 100. So I just type 100, and then I just keep on typing, and then I put all the data in this table. And if you look, just want to get rid of this. Okay, if you look down, you're gonna see that we have several values. We have A and B. Right now, A will be 42 and B will be 1.09, which is actually far from the 1.3 that we expected. But you have to guys think that we don't have enough data here. We need to put more data. This value R, it's how close these values are to a perfect exponential. This is not exactly a perfect exponential because we're gonna have 1 point here, 1 point here, 1 point here, 1 point here. I'm exaggerating, right? But what I'm trying to tell you is that real life, it's not exact. So even we will have these points like this, and we'll try to find a function that fits them. Okay, so we're trying to find a function. It's not gonna go through all of them, but as close as we can. We have to find something as close as we can, and that's what a regression means. And a regression, when it comes to math, it's a little bit complicated. So we don't want to see what do we have behind this calculation of this function, but at least we want to be able to use it. Okay, with Desmos again. So this number, the closest it is to 1, this R, the closest it is to a perfect regression. Okay, so 0.91, that's pretty good. It's pretty good. So if we fill all the data to up to this day, what was yesterday, 23rd of March, that's what we have when we put all the data in. Look at this. So look at this. We have this is the regression. As you can see, not all the points, which are the data, is the green points, and the regression that Desmos has found is this orange exponential. Okay, so this is we can use this orange line to predict what is gonna happen in the future if we don't take action, right? As you can see, this goes really fast. Actually, last week we predicted that around today we would reach the 50,000 cases, which is actually pretty close. We're gonna reach today the 50,000, right? So if we look at the data here, I've put all the data. We have like 19 rows. The more data we have, the more exact it's gonna be. And what do we get for A and B? We get for A, we get 20, and for B, we get 1.289, which is actually close to 1.29, which is, as you can see, really close to 1.3. So that means that the function is 20 times 1.29 to the power of x. Okay, so the day 29th we have 43,734. If we want to know what's going to happen tomorrow, we have to use 20 times 1.29 to the power of 30. And if you do that with the calculator, you're going to know more or less what it's going to be the number of cases we're going to have today. Okay? That's the prediction of this regression function. Okay? Have a great day. Bye-bye.